There we go.
Woohoo! We're live. I've always wondered
So, what
what.
do you think about the this chapter?
Um, I think it's interesting. Um, I I'll be honest with you. I didn't get to go in real depth with it because I did just kind of skim it. But I don't know. A whole probability
Okay.
thing. I don't know. It Part of it makes complete sense to me, but then the other part of it is really confusing.
Yeah. The the finding the mean, I understand. It's fairly easy, especially when you're talking about dyes and stuff, because
Right.
each one has the same probability. Um, but the standard deviation is where I kind of got lost.
Standard deviation. Yeah,
And I get the
did you already do part two of the preparation assignment? That was one that we were supposed to do ourselves this time. Oops.
Yeah, I went ahead and did five because, like I said, that was fairly easy.
Hmm.
The mean I understand. Six was a lot harder to me. I'm not understanding the standard deviation part of it. Um, by reading the chapter where it looks like what this where they use the experiment where they actually rolled the die like 6,000 times. Um, I understand the 3.5030. I understand where they get that from. Um, but I'm not understanding the math involved with the standard deviation.
Okay. Let me get to the same place you're at. Are you?
I'm
Let's
kind of looking at the example in the book,
the one.
and it shows about three different ways to find the mean, and I understand all those.
Okay.
I understand how they got the mean. Um,
But then right below
if
that,
you
when
go
they're
like
going into standard deviation. Okay.
where they're talking about the standard deviation, that's where I lose understanding, I guess.
All right. So it's the one in the
And I have a feeling that one of our questions will probably have to do with standard deviation. So,
I wouldn't put it past them. So this formula that they have here, um, the difference of x and is that mu? The,
uh
the difference of x and mu squared times um, the probability.
hmm
I don't know. I feel like in each of their examples of finding the standard deviation. Oh no, never mind. Never mind to that. Never mind.
Okay.
it, it looks like that equation is how to find the standard deviation. And you've probably already gotten to that point.
Yeah, I found the mean, and I mean, I'm guessing it would vary if our probabilities were different, standard die or whatever, but since your probability is always going to be the same, whether you're using the 4 or the 6-sided, your mean's just going to be right in the middle because you've got odds on either side. So I understand that. I understand how to get that. The probability times the number divided by
Hmm.
um, essentially the times they were rolled. Um, but I'm not.
Hey, just a second, Bernie. I'm gonna plug in headphones. I'm having a hard time hearing you.
Oh, okay.
Can you still hear me?
Yes. Can you hear me?
Yeah, I can. Just not. How's that?
I can still hear you. Can you hear me?
Yeah, I can, but headphones did not work. So
Okay.
that's okay. We're doing okay, I think.
I mean, I
Okay,
guess I get the math on it. I just.
let me. So to find the mean, okay, so first of all, to find probability, it's just going to be 1 over 4 is going to be the
Mm-hmm.
probability of what we're going to get for each die, or each time we roll. Or that didn't make sense.
Probability just it's the same. Yeah.
Okay, okay. And that's equal to 0.25. I'm just scribbling some stuff down to see if it makes more sense to me if I write it down.
Okay.
And so that is our count. And then the mean, we're going to calculate that by multiplying the value by the probability.
Mm-hmm.
Is that right? And then we take the sum
Right,
of.
and then adding them up.
Okay. So then we take
So you'd be
1
at
times.
0.25, 0.5, 0.75, and 1.
Okay. Okay. And so our mean that we come up with is, hold on, let me pull out my modern day calculator. I think calculators are the best inventions ever.
Yes, definitely.
Okay, so the sum of all those is 0.25. And so that's our mean, which, like you
You
said, is smack dab
mean
in the.
2.5?
Yeah.
Yeah,
Okay.
which that makes sense to me since nothing has a higher probability of anything else. Your mean and your median is going to be pretty much the same thing.
Okay. Right. Right.
Um,
And so your standard deviation has a weird. So let's go back and let me make sure that I understand standard deviation because I think that I do. Oh no.
okay, what? Okay.
Sorry about that, Bernie.
Oh, that's fine.
My computers are just having all sorts of troubles tonight. Okay, well, so standard deviation, that is basically the spread of the majority, but it's the spread of the data in in a graph.
Um,
Well, not that's a really simple way of looking at it, but that's the basic part of it, right?
right. It's kind of it's how far from the average your data is going to go.
Okay. So in the case of a four-sided dice, for at 0.25, then it can go either down to 1 or up to 4. Hmm.
Yeah. And so there, um, the math that they show to do it is uh, your value or your result, which would be a one, a two, three, or four, times or minus
The
your
mu, which is your
yeah minus your
average,
mean yeah
or yeah, mean, sorry.
minus your mean squared times your probability. Uh, so if you do that for every one, and then and add them up, and then do a square root of that, it should give you your
Your standard deviation.
so let's try the example here. We would have 1 minus 2.5 squared times 0.25. Okay, so have you done the first two? First one?
So I'm just finishing up the last one right here.
Okay.
And we're doing it with the four-sided dice, right?
Mm-hmm. We're
So for
doing the one for the homework.
okay, so for that first one, I got 0.1406, and then the next two were 0.2625.
Okay.
Is that what you got as well?
Let me do number one again.
And I might have done it wrong, so let me also.
0.5625 for the first one.
You got what? 5, 6.
0.5625.
Okay. Okay, yeah, I just redid it, and that's what I got as well. I just made a mistake that first time. Sorry.
Oh, that's fine. Okay, so, and then 0.0625 for the next two, and then I got 0.5625 for the last one as well.
Right. And then all of that adds up to 1.25. And so that number
And then
right
they said
there,
the square root of that. What?
so that 1.25, that's not our standard deviation. That's
No,
our
that's the variance.
okay.
The standard deviation should be the square root of the variance,
Okay.
from what the math shows.
Which would be 1.118
Mm-hmm.
and other stuff too, but
Yeah, they rounded out to 0.118 on the homework, so.
okay. Okay. Square root of variance. Did that help you to work that through?
Hmm?
Did that help you to go through that little part? Because I can tell you it helped me.
I think it did. It's just going to be remembering the math on it. It's fairly easy to see. It's just going to be, like I said, remembering what the formulas and things are for it.
Right. So mean, so it's our value minus the mean squared times the probability. And that's to get the variance. Okay. And then let me just make sure real fast that let's see, the discrete random variable is just something that shows a pattern,
Oh, yeah.
or is a variable that shows a specific pattern.
Yeah, I think it's hmm.
Okay.
Okay.
Okay. I I think Bernie that I think we're at the same level now. I think that I understand all the stuff from the homework. That's good.
Okay. You want to try the Whitney test?
The quiz thing.
Mm-hmm.
If you're if you feel like, yeah, let's do it.
Yeah.
I've got my scratch paper and my calculator right here. What else do I need? And you're here too.
Okay.
All right. So starting. Let's see. So everything's all probabilities or it's decimals. Don't do it as percents. Okay.
Mm-hmm.
Okay, so true or false, the blood types and proportions given in the table define a probability distribution.
I would say true.
I agree. Because a probability distribution, um, that's with the probability distributions, there's the three rules that it has to follow. Is that right? Or is that the, am I mistaken?
Let's see. Well, there's a three rules of probability.
Okay.
Um,
Okay, yeah,
motion.
I think it is true though.
Okay. So
What's the what's the probability that a randomly selected person in the United States will have type O blood? Oh,
wouldn't that be 0.45?
that's what I think, but at the same time, I feel like where it says rounded to decimal places, I feel like we're supposed to calculate something. But
Hmm.
according to the question, it makes sense that it's just 0.45.
The table's saying out of 100 people, 45 are going to have type O, 40 is going to have A, 11 will have B, and 4% will have AB. So to me, that means O would be
Point.
45% have O, or 0.45 would be the decimal, right?
Right. Yeah, I think that's right. Um,
They were out trying to outthink ourselves. I don't know.
I don't know. I guess let's. I'm just gonna try not to overthink it because I'm really good at overthinking questions. That's my downfall. So so going on. So 0.45 is the probability that they'll have O-type blood. So the next question, what's the probability that the randomly selected person will not have type O blood? That would just be the sum of all of the other probabilities,
That's what I would think too, which would be
which would be
0.55.
yeah. Okay.
Just 1 Okay, so on 6, we're just doing 1 divided by 7, basically, right?
Yeah. See if it gets at random. Yeah, because there's a 1 in 7 chance that it's a bladder cancer patient. So round it to 3 decimal places, so 1.43.
Mm-hmm.
Sorry, 0.143.
0.143, yeah.
So then in the combined trial, 54 trials. Okay, so they're testing to see if they're actually able to detect bladder cancer. So let me make sure that I understand this question right. So 54 times there was a specimen that had bladder cancer, and out of that 54 times that they tried it, the dogs were able to identify it 22 times.
Mm-hmm.
Okay. Um, so then, ooh, that's not quite half of the time.
Yeah, but it's uh, better than random, so
True.
because if you did you do the reading where it talked about Columbus and the chickpea or whatever, and he got 3 out of 4 of the chickpeas, and they talked about what a small um,
No, I didn't do that part.
okay. Well, okay, if one test is 0.143 probability, so 14 essentially, basically they did like the story is about Columbus drawing out chickpeas or whatever,
Okay.
and he everybody on board had to pick a chickpea for something, and the chance that he would draw it 3 out of 4 times was like
Really small.
less than of 1/2 of 1/2 of 1%. It was extremely small because you
Because
essentially times the probabilities by themselves. So
okay.
I'd have to say that that would provide strong evidence, wouldn't you think?
Yeah. Yes.
Okay.
I'm sorry.
Okay.
I'm not putting in much help tonight.
Oh, you're fine. I felt like I didn't put in a lot of help last week, so
Hey,
What?
Kitty's getting underfoot. You hold her.
No.
Okay.
That's my wife.
Hi.
hi. Okay. Um,
Okay. So I think this probability of M&Ms, classic.
okay. So red's got to be 0.13 or a 13% chance, right?
Right. Because that's the distribution of colors they give us. Make sure that you put a period though, not a comma, because it'll probably mark it wrong.
Okay. So what did you get
For the second one,
for
I am just about there. Just 1 second.
okay.
0.16.
Okay, that's what I got too. So I think we're good there.
Okay.
Uh,
And then 0.84 if it's not green.
yeah, that's what I got as well.
Okay. Ooh, ACT scores. Yeah. I don't miss the ACT. Actually, the ACT wasn't that bad.
Okay, so 11. Half the observations are less than or equal to what number?
So less than half of the observations. So this is from last week.
Yeah.
So um it'd be 24 because that's our median, and that's like the 50% mark. Is that right?
Well, median is, from what I understand, median is just the midpoint of all the numbers. So if you have someone that got 37 and everybody else got 12s, your median is going to be really high um, because it's going to be the halfway point. I would say it's 24.3, which is your mean.
Okay.
I mean, what do you think?
I'm, I think it's. Ooh, I see your argument for the mean makes sense, but I'm just thinking of the box plots, and because let's say it was. Let's reword this question to where it was the 50 percentile of the data. Well, because is that pretty much the same thing that it's asking?
Yeah, I think your 50 percentile would be what it's asking.
Okay, which if it's the 50 percentile, then because the 50 percentile and the median are the same thing, just like the 25th percentile and the first quartile are the same thing? Is that right?
I still think it's mean because um, mean's going to be your average, which should be your 50%.
Right, but with the mean, if with the mean, it doesn't
Because
mean
median, where
that
there's
there's actually a score of that number. Oh, but yeah, I don't know. Uh, let's see. So our minimum's 14,
right.
maximum's 35. I'm just kind of thinking out loud. Um, the standard deviation is 4.3, so the majority of the data is going to be in there. Me, I'm just going to go. Wait, I forget. Are we allowed to? We're allowed to use notes on this quiz, right?
I believe so.
Okay.
If we're allowed to use each other, I can't see why we can't use.
Good point.
Um, oh, let me see. You might be right.
I can't open up my notes at all, so. Oh, wait. There we go. Okay.
Says the median is the middle value in a sorted data set. Half the observation in the data set are below the median and half are above the median.
Is that from the book?
Mm-hmm.
Oh, okay. Well, I can tell you what number 12 is.
12's easier, yes.
12's easy. 27, right?
Right.
Okay. Um, I'm thinking, I don't know. I think that it's 24, and especially from what you just read, that too.
Yeah, 11 I would.
And so I don't know, the mean and the median are so close together though. Like, I need to work on understanding the difference between those. I mean, I understand the difference between them, but how I can use those to make more sense or to present data better. That's what I'm trying to say.
Yeah. Okay, and then do you have 13?
Um, well, it's not the first one,
Mm-hmm.
and it's not the third one. that second one, right? Because that third one, the probability of an outcome will not occur is 1 minus the probability that it will occur.
Okay. Yours must be in different orders than mine. So I've got the one that's not as if the probability is high, then the probability is positive, the probability is low, then the
Right, right.
probability is negative.
Yes, that's also the one I have.
Okay. So we submit it.
Let's go for it. Cross my fingers.
Yay!
Nice. Well done, Bernie. I'm glad that you did more than just skim. I promise I won't next time.
No, that's fine. Like I said,
Um,
I had such a hiccup on SPSS last week that
so is there anything else that you want to go over right now?
not in this lesson necessarily. I haven't even looked at the next one. I
Me
think I'm
neither.
good.
I have this idea that eventually I'll get ahead of myself and I'll be a lesson ahead, but I don't know if that'll actually ever happen.
Yeah, I
Yeah.
get those ideas too, but